Hello everyone, welcome to the next tutorial. In this tutorial, we are going to find the total resistance of the resistor combination when they are connected in parallel with each other along with the current division between them. Okay, so let's say the total resistance or the equivalent resistance of this particular resistor combination is your R equivalent. Okay, so after according to KCL, what we can see is 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 equal to I1 plus I2, where I1 and I2 are the currents which are flowing through the resistors R1 and R2 respectively. Okay, so according to Ohm's law, we know that V will be equal to I1 times R1. So I1 will be equal to V by R1. Similarly, I2 will be equal to V by R2 and Is will be equal to V by R equivalent. So R equivalent is the total resistance of this particular resistor combination. Okay. So after substituting these in this equation, what we can say is V upon R equivalent will be equal to V by R1 plus V by R2. So it means that 1 upon R equivalent will be equal to 1 by R1 plus 1 by R2. Okay. So this is the total resistance or the equivalent resistance of these resistors which are connected in parallel with each other. Okay. So it means that for n resistors and resistor combination which are connected in parallel to each other, so connected in parallel with each other, so R equivalent, 1 upon R equivalent will be equal to 1 by R1 plus 1 by R2 plus so on 1 by Rn. Okay, so this is a very important expression and you need to remember it. Okay, now let's find the current division. Let's find the current division in this particular network. Okay, so we know that V is equal to Is into R equivalent. Okay, so we know that 1 by R equivalent will be equal to 1 by R1 plus 1 by R2. So it means that R equivalent will be equal to R1 R2 upon R1 plus R2. Okay, so substituting the value of R equivalent in this particular equation, so we will get V will be equal to Is into R1 R2 over R1 plus R2. Okay, since we already know that V is equal to I1 into R1 is equal to I2 into R2. So substituting the value of V in this particular equation, we can get I1 R1 is equal to Is R1 R2 upon R1 plus R2. So R1 is cancelled out with R1 and we are getting the value of I1 to be equal to, so we are getting the value of I1 is equal to Is into R2 over R1 plus R2. Okay, similarly the value of I2 will be equal to, so I2 will be equal to Is into R1 upon R1 plus R2. Okay, so the value of I2 can be redefined as I2 will be equal to Is into 1 upon R1 R2 over 1 upon R1 plus 1 upon R2. Okay, so from this particular equation, we can see that, let's say if a electrical circuit, so if a electrical network or a circuit have n resistors connected in parallel, so connected in parallel, okay. So connected in parallel, the value of the current distribution for nth resistor, the current distribution for nth resistor, or the current that is flowing from the nth resistor will be given as, so it will be equal to I of n is equal to I of s 1 upon Rn upon 1 upon R1 plus 1 upon R2 plus so on 1 by Rn, okay. So this whole term is your 1 by R equivalent. So this is again one of the most important expression which you need to remember. So that's all for today, guys. I will see you in the next tutorial. Thank you.